So today we're going to be covering the first part of the unit circle. And now the unit circle in and of itself, we're not going to visually see what's going on right now, but we're going to create a system of coordinates which is going to give us some basic values which are going to form the foundation of trigonometry. Now the unit circle is typically measured by an object orbiting. If you look down at the object orbiting as it circles around, you record its position in space with two things: the position on the x-axis and the position on the y-axis. If it's over here, it's 1. If it's up here, it's 1. It's over here, it's -1. And down at the bottom, it's -1. And as it rotates, it's going to rotate between those values. Now, these are going to be read as a slightly different mechanism. The secondary variables is the distance from the center to the orbit, the radius, the orbital radius, and the angle it creates between some horizon and the position. Another definition for trig is the study of triangles, which is what we're going to be creating and turning into a circle. If you want to turn a circle into a triangle or a triangle into a circle, a little bit of both. So we're going to practice, given a radius of 1 unit, one generic unit, not in feet, not in inches, not in miles, 1 unit, give the coordinates of the object in orbit. I want to find, as it moves around the circle, what is my x and what is my y value. So let's take a look. Now, 30 degrees and pi/6 radians, whichever one you prefer, we're going to use those. Just make sure your calculator, if you're using a calculator to double check, is in the proper mode. So if I have a radius of 1 unit and I have an object at 30 degrees, first off, I know that my 30 degrees as this object is rotating around is going to give me a 60-degree angle right here. That's going to look a heck of a lot like our special right triangle of 30, 60, 90, which is 1, 2, square root of 3. The only problem is it's not a 30, 60, 90 as we know it. This has a radius of 1, which means what did we multiply our standard 30, 60, 90 by to get the new one? Well, we multiplied it by 1/2. So in order to find the other two values, I'm going to have to multiply both of those by 1/2, which means that if I have a distance of 1, let's write it like this, so 1 and square root of 3, multiply this times 1/2 and this times 1/2. So I know for this aspect, my x value is going to be the square root of 3 over 2, and my y value is going to be 1/2. Easy enough. Now, if I do this with a 60-degree angle, it's going to change slightly. Let's do, okay, so 60 degrees. So this object has now orbited all the way up there, 60 degrees. Now to find the x and the y, I know that's going to be, again, a 30, 60, 90 triangle. So 1, 2, square root of 3. So I just need to figure out, okay, if I have a radius of 1, what did I multiply this triangle by to get that? Well, again, the answer is, again, going to be 1/2. So that means that I'm going to take my previous value of 1, which is opposite 30, and square root of 3, and I'm going to multiply it by 1/2. So this time my x is 1/2 and my y is square root of 3/2. Awesome. Now, with my 30, 60, 90 triangle, it's not too bad. What about something like number 6? I have 135 degrees. So now in this case, the object has orbited all the way over to about right here. So I have a radius of 1. And if I want to find out what the x and the y are, well, that's 135 degrees. I need to figure out how much is left. So I'm going to take a value of 180. Actually, let me fold this up on the screen. If I have 180 degrees and I take away 135, that leaves me with 45 degrees, which means that this is a 45, 45, 90 triangle. which is 1 square root of 2. And so I'm going to ask myself, okay, knowing that this is a 45, 45, 90, what did I multiply my original triangle by to get this? How did square root of 2 become 1? Well, that means I must have divided by the square root of 2, because square root of 2 divided by the square root of 2 is going to leave me with a 1. So I'm going to take both my values, in this case a 1. In this case, it's not just a 1, but because we are now left of the axis, it's going to be a negative 1. And I'm going to divide them both by the square root of 2. And so if they're both divided by the square root of 2, 1 over the square root of 2, if I rationalize that, is going to be the square root of 2 over 2. And if I take negative 1 over the square root of 2, that's going to rationalize as negative square root of 2 over 2. So x is negative square root of 2 over 2, and y is just the square root of 2 over 2. Perfect. So I want you to take a pause, try out 180, and see how well you do. Okay, let's take a look at number 8. 180 degrees. Now with this, I've rotated all the way around until I'm right here. So if I still have a radius of 1, I don't need to draw a triangle like this because there's no x and y coordinate that I'm trying to figure out a partial value of. I know that my x is just going to be straight negative 1, and I don't have a y because it hasn't raised up off the axis. It's actually hit the other side. So my x is negative 1 and my y is 0. So not bad. And that's going to bring us to our next set. Really, this is just more values of the unit circle. So what I want you to try is I want you to take a pause and I want you to try, let's take a look at this. How about number 10, number 12, and number 15. So try number 10, number 12, and number 15. Pause the video, unpause it when you're done, and see how well you did. Okay, so let's take a look. Number 10, 225 degrees. I know that on the circle, that's not quite 3/4 of the way, but I have gone somewhere over here. So I have a spot right there, and I know that if this is radius 1, I want to figure out what my x value and what my y values are. So I'm going to say, how far past 180 did I go? 45. Which means that I'm looking at a 45, 45, 90. I know that to get this equal to a 1, I am dividing by the square root of 2. So I'm just going to take my 1s and divide them by a square root of 2. But in this case, this is a negative 1 and this is a negative 1. So both of them are a negative 1 divided by the square root of 2. Rationalized is negative square root of 2 over 2 for both my coordinates. Awesome. 270 degrees. Number 12. We can knock that out. Pretty easy. At this point, I have made it all the way around to that right there, which is no longer a triangle. I just know that this is directly down. So my x has no value and y is negative 1. With length 1, that's actually down 1 unit. Number 15 at 330 degrees. I have made it past that, and I've gone all the way to right there. So if that's 330, I've only got 30 degrees left before I close the circle completely, which means that this, if that is a unit of 1, that must be a 30, 60, 90 triangle. One, 2, square root of 3. So I'm going to take those values. In this case, opposite my 30 is 1, so that must mean that this is negative 1, Opposite my 60 is the square root of 3. And I got to figure out, okay, how did I get my radius to go to a 1? Well, I must have multiplied by 1/2. Take both of those and divide them by 2. So my x is square root of 3 over 2, and my y is negative 1/2. And there we go. So that brings us to the last question. What do you think will happen as you move beyond 360 degrees? Further describe any other patterns you see in the values you've discovered and attempt to give an explanation of why they may occur. So what's going on right here is it reverts back to where our start was. We're orbiting, which means that once we've completed one orbit, we begin again. So if we move beyond 360 degrees, what happens at 390 degrees? Well, 390 degrees is one full circle and 30 degrees back. So we'll get our same values as we did right here. Put that into your own words, and there we go.